Hello students, today we are going to solve some more problems related to the algebra. The first question is a pair of linear equation in two variable x and y with b1x plus c1y is equals to a1 and c2x plus a2y is equals to b2 has infinite number of possible solution if one of the following conditions holds. As we know that if we have a linear equation, pair of linear equation, that is a1x plus b1y is equals to c1 and a2x plus b2y is equals to c2, then the pair of linear equation will have infinite number of possible solution if a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. Hence, for this set of equation, the final solution will be if b1 upon c2 is equals to c1 upon a2 is equals to a1 upon b2. That means the final answer will be this solution D, that is b1 upon c2 is equals to c1 upon a2 is equals to a1 upon b2. Next question is, consider the following quadratic equation. We have ax square plus bx is plus c equals to 0, where a, b, c all belongs to the complex number. Which of the following statement is true for this equation? These are quite easy questions. The solution will be, as we know, the coefficients are complex. Then the root will definitely be complex number but need not to be in conjugate pair. Hence, the correct answer will be option number C, that root will be complex and need not to be conjugate pairs. Next question is, if x is not equals to 1 is any real number, then x cube plus 1 greater than x square plus x, this equality will hold if and only if x is equals to minus 1, x is greater than minus 1, and it does not hold for any real x and x is less than equals to minus 1. Let's try to solve this. We are given that x cube plus 1 is greater than x square plus 1. Means this can be written as x square plus x plus 1 into x square plus 1 minus x, which is greater than x into x plus 1. Means we have x square plus 1 minus x is greater than 0. That means we have x square minus 2x plus 1 equals to 0. This is nothing but x minus 1 whole square. When we solve this, we will have x is greater than minus 1. That is your final solution. Next question is, the number of real solution of the equation x square mod of x square plus 5 mod x plus 4 is equals to 0 are 4, 2, 1 or 0. Let's try to solve this question. As we know that we are given with x mod of x square plus 5x plus 4 equals to 0. Just rewrite this equation. You will have mod of x plus 4 into mod of x plus 1 equals to 0. That means you will have either mod of x equals to minus 4 or it is equals to minus 1. That is not possible because this is mod function and the value of mod cannot be negative. Hence, it is not possible. The solution is not possible. So, the correct answer is 0. Next question is, the root of the equations 3x square minus 4, plus 4x plus 7 equals to 0 are alpha beta. Then you have to calculate the value of 1 upon alpha plus 1 upon beta. If alpha and beta are the roots of 3x square plus 4x plus 7 equals to 0, then the value of alpha plus beta will be equals to minus b upon a, that is minus 4 upon 3, and alpha beta will be equals to c upon a, that is 7 upon 3. Hence, just simply calculate the value of 1 upon alpha plus 1 upon beta, that is alpha plus beta upon alpha beta, that which comes out minus 4 upon 3 by 7 upon 3. The value of this will be calculated as minus 4 upon 7. Hence, for this given equation, the value of 1 upon alpha plus 1 upon beta will be comes out as minus 4 by 7. Next question is, if x minus 1 is the factor of x raised to the power 5 minus 4x cube plus 2x square minus 3x plus k is equals to 0, then the value of k. This is very easiest question, I think. You simply have to put the value of x equals to x equals to 1 in this equation, and you will have your final answer of k. That is, and it will, when you solve this, it will come out as k equals to 4. As we know that 1 minus 4 plus 2 minus 3 it will come out as 4. The final answer of k will be 4. Next question is, how many real solutions are there? You are given with the equation x raised to the power 4 minus 1 equals to 0, and you have to find out how many real solution for this equation does exist. Is it 4, 3, 2 or 1? Let's try to solve this equation. You are given with x raised to the power 4 minus 2 is equals to 0. It can be written as x square minus root 2 into x square plus root 2 is equals to 0. Then we have either this factor will be 0 or this factor will be 0. This we cannot accept since there are no real numbers where square is negative. So when x square minus root 2 is equals to 0, you will have x equals to plus minus 2 raised to the power 1 by 4. Means you have two solutions. That means for this equation, x raised to the power 4 minus 2 equals to 0, we have only two solutions. Next question is, if sine theta and cos theta are the root of equation ax square plus bx plus ax square minus bx plus c equals to 0, then a, b and c satisfies the relations. Simply just calculate the values, sum of roots and multiplication of roots, and then try to simplify this. Means you are given with this equation, simply a plus b, sum of roots, that is sine theta plus cos theta will be equals to b upon a, and sine theta into b cos theta will be equals to c upon a. So simply sine theta plus cos theta, this whole square will be comes out as b upon a, this whole square, that is sine square theta plus cos square theta will become 1 plus 2 sine theta cos theta will be equals to b upon a, this whole square. The value of sine theta and cos theta will be c upon a. Means when we solve this, you will have this a square plus 2ac is equals to b square, and it can be also written as a square minus b square plus 2ac is equals to 0. Next one is, if the root of the equation y square minus root 2y plus root 3 are alpha and beta, then alpha raised to the power 4 plus beta raised to the power 4 will be either 16 plus 8 root 3, 10 minus 8 root 3, 13 minus 12 root 3 or 13 plus 12 root 2. If alpha and beta are the root of this given equation, then alpha plus beta will be root 2 and alpha beta will be equals to root 3. Simply calculate the value of alpha square plus beta square. It will become as, it can be written as alpha plus beta this whole square minus 2 alpha beta, and by putting the values we will have 2 minus 2 root 3. This will come out as 2 minus 2 root 3, and further calculate the square root of this. Further calculate the square of this, you will have alpha square plus beta square, this whole square will be 2 minus 2 root 3, this whole square, which can be further written as, further can solve as alpha raised to the power plus beta raised to the power 2 alpha raised to square plus 2 alpha square beta square. It will be 16 minus 8 root 3. Alpha raised to the power plus beta raised to the power 4 will be equals to 16 minus 8 root 3. And we know that alpha beta is equals to root 3. So 2 into alpha square beta square will be equals to 6. That means the final solution will be 16 minus 6 minus 8 root 3, that is 10 minus 8 root 3, and the final answer will be 10 minus root 3. Next question is, this is the easiest question of all. A product of R consecutives natural number is always divisible by. The answer is R factorial. As you know that the product of R consecutive natural number is always divisible by R factorial. Thank you.